Hey, I'm Charlotte, and I'm here to talk about artificial intelligence. Did you know that there are 7 senses in our bodies, not 5? The first 5 you probably already know. Your sight, your hearing, your sense of smell, your sense of taste, and touch. And the other 2 might come as a surprise to you. They are both proprioception, which is how you know where your body is in space, and your vestibular system, which is your sense of balance. And those 7 things together make up how you perceive the world. Now, computers, in order to do the work that they do, also need to perceive the world, and they use those same 7 senses. So vision, for example, you may be able to take a picture or a video, and that would be a perception of a computer, but it might also be a picture of using a telescope or using a microscope to see something that our eyes would never be able to perceive without the help of technology. It might also see wavelengths of light that we can't see, such as ultraviolet light, that other animals can perceive. Humans have a sense of smell that we use to sense emotion and to know what's happening around us. So for example, if you walk home and you walk in the door and you smell cookies, you probably feel really good. If you walk in and you smell fire, you might feel worried. A computer can also smell. It can have a fire detector that's connected to the fire department. So before you even get home, the fire department has already come. That computer system can detect the chemical signature of fire and keep you safe. You may have gone through an airport, and if you bring food through that airport, they need to test it and see that the chemicals are the things that they should find in food and not something that's illegal for an airplane. So they'll bring out a little pad and they'll rub it on the food, and that is the way a computer might taste. So another sense we have is touch. And for us, it seems very natural. We can pick up a pen, we can pick up a phone, we can pick up a heavy brick. And we know exactly how much force we need in order to pick up each one of those objects. One of the challenges that computers and robotics have is knowing how much force it takes to pick up a single object. So when you see that 6-month-old picking up Cheerios, they're learning how not only to move their body in that way, but how much force it takes so that you can get the Cheerio and grab it with just enough force that you don't crush it. So robotics are still learning some of those systems of touch. A computer can hear things both at a higher and lower range than we can hear, and it can hear at a faster or slower rate. So some sounds computer can perceive and analyze, and we have to see it on a graph, because it's just too fast for our ears to hear. That vestibular system, that sense of balance, that's a challenge for computers right now, that they have to be able to orient themselves in space. And you're probably thinking like a robot, right? Like it's trying to walk, and we know that computers don't really do that well yet, those robotics yet, but we have that sensor right here in our phones where we can play video games, and that has that orientation in space. Your GPS knows if you're going east or west or north or south, and that's proprioception. That's knowing where it is in space. So we also have that with the vestibular system, that sense of balance. That's where robots really struggle, is can they walk up the stairs? That's a challenge for a robot because it requires a lot of different sensors and motors to work together very finely together, where the timing has to work out just right, where it can adapt. And we're really good at adapting. Computers aren't as good at adapting. What they are good at is finding patterns. So when you have these 7 senses and they all come together, we can put computer processing behind it, and we can do amazing things. Hi, I'm Charlotte, and I'm here to talk about artificial intelligence. Last time we talked about sensors and perception, both for computers and for humans. But what happens with that data once it comes through a sensor determines whether or not it's processed with a traditional computer or with an artificial intelligence system. Let me give you an example. Imagine that you're planning a birthday party at a roller rink, and you want to spend $200 to rent out the rink, and they also charge $6.50 per person that comes to the rink. You could put that in as $200 plus $6.50 times the number of people, or 650p. That's traditional computing, where we have a function and we run some numbers through it and we get an output, the amount that you're going to pay for the birthday party. In artificial intelligence, we do it a little bit differently. We start with the input and we have the output, and we don't figure out the middle. The computer figures out how to get from the input to the output. How it gets that is by successive approximation. That means it gets closer and closer every time. It'll try to come up with some numbers that make those variables work out to calculate what the rate will be over time. So if you're an AI system, you'd get the input of 4 people, and the cost is $226. 10 people, $265. 14 people, $291. 20 people, $330. So in traditional computing, we give the computer a math problem, and it plugs in the numbers and gives us an output. In artificially intelligent programs, we have an input and we have an output. We have a lot of pairs of data, those values, and it uses its own math to determine how the pattern should evolve. Here's another example. We're shopping for our party and we're going to the grocery store. As you walk in the door opens, whoop, and as you walk through, it closes again. Now that is a sensor. It knows that you're there, it opened for you, but it doesn't know that you are you. If you walk through that same door and the door opens and it says, "Hello, Charlotte," and as you're checking out, you scan that card so that you get your coupons. Well, that data is being used by the company that you're purchasing from. So let's say you scan that card and immediately some coupons come out, and they're for about the same thing that you're buying right now. If you're buying a cake mix, you're probably getting coupons for other brands of cake mixes. If you're buying 3 pints of Ben & Jerry's, you're probably getting a coupon for buying 4 or more. And that's not an artificially intelligent system necessarily. That's just that input versus output comparing. What happens is, if it knows you're having a birthday party and you get coupons in the mail next week that offer presents that would be tailored to your family, that's an artificial intelligence system. Well, how does it do that? Well, it does it with a lot of data. So, if you walk through the door, that's a sensor, not AI. If you get personalized information using lots of data, that's a neural network. Hi, I'm Charlotte, and I'm here to talk about artificial intelligence. Did you know there are 5 big ideas in AI? They are perception, representation and reasoning, learning from data, natural interaction, and societal impact. Number 1 is perception. Perception is when a computer uses sensors to gather data and then extracts meaning from those signals. Number 2, representation and reasoning. Representation is when a computer builds its own world so that it can understand, just like a Google map. That's an example of a representation of how the computer perceives the world. Then it can apply reasoning to that representation. For example, to take you on the correct bike path or to route you via Uber. Number 3, learning from data. Computers use a lot of data to do the processing that allows them to think artificially. That's artificial intelligence. Almost all AI systems are made from a lot of data. Number 4, natural interaction. Natural interaction is when we've trained an AI system to interact naturally with the people around it. That means that you can trust Google Translate to say the words that you're saying in another language, or perhaps you use facial recognition and you trust that that system will only let the correct people into the building. Number 5, societal impact. AI affects our world in positive and negative ways. AI makes it so that no one in the world starves. But we also have to make sure to guard against implicit bias and make sure that the computer algorithms that we write are fair for everyone. So these are the 5 big ideas in AI: perception, representation and reasoning, learning from data, natural interaction, and societal impact. Watch more videos to learn more in depth about each of these ideas. Hi, I'm Charlotte, and I'm here to talk about artificial intelligence. Have you heard of recommender systems? Recommender systems are AI computer algorithms that track your habits, your likes and dislikes, your beliefs, how much money you have, and where you are at any given time. These recommender systems help you to choose music and video that you would enjoy based on the things you've watched in the past, or people like you have watched in the past. The ads that you see on the internet, in social media, and on apps, if you've ever had that feeling like you thought about it and it appeared, it's probably because people like you have enjoyed those same types of things. Or maybe you've clicked on an email link and now it's recommending things that you would like. Recommender systems provide coupons for you, and they know which products you're likely to buy, even if you've never purchased from that company before. Recommender systems are also used in sentencing and bail in the justice system, so that judges know whether or not you're likely to reoffend. Insurance companies use recommender systems to know whether or not you're a risk, and your credit may be influenced by these recommender systems that are used by companies. Even elections and the news you see can be influenced by recommender systems, which changes how people think about the world. These recommender systems are built by data aggregators, companies like Palantir, Datadog, and First Data, who are spending billions of dollars and earning billions more to take these tiny bits of data about you. Every email you read, every web page you visit, every social media app that you use, the location data from your phone. When you watch or listen to anything on your television, these data aggregator companies bring all of that data together to build a very specific profile of people like you. We need to ensure that these data aggregation companies reduce bias, that they show appropriate content to adults and children, and that everyone knows how to protect themselves when they have data that they don't want to share, that's personal. We need to make sure that data aggregation companies and recommender systems benefit all people.
Hi, I'm Charlotte, and I work in artificial intelligence, or AI. AI is a computing tool that helps people use data to solve problems. Doctors use AI to find new medicines. Lives can be saved when planes, trains, and cars navigate themselves. AI can be used to improve harvests for farmers or to protect the environment. Did you know we have satellites that monitor zebras from space, reading their stripes like a barcode? The uses of AI can go way beyond making awesome new movies and video games. This kind of computer programming personalizes experiences for you, like when your phone recommends a new song that you might enjoy based on what you've listened to before, or predicts the next word you might want to use in a text. Snapchat filters are AI. And it can be used to create learning experiences that work for every student. It's all around us, and AI is powerful. When you see something wrong in the world, you can use artificial intelligence as a tool to solve big problems in ways that individual people could never imagine, like giving the internet to people in places where there aren't even roads, or making sure the elderly population isn't lonely with robot companions. AI can even remove human bias from decisions, so hiring for jobs is equitable and people are paid fairly for the work they do. We need you to learn computer science and use artificial intelligence to create systems that make the world a better place. Plus, it's really fun. Be a creator of technology, not just a consumer. Whatever career you're interested in, AI can help you do your job better, and you can start learning today with a simple web search.
Hi, I'm Charlotte, and I'm here to talk about artificial intelligence. Last time we learned about recommender systems and data aggregators. How do those systems work? They work by AI sorting algorithms that help us to identify and match what we're looking for. Here's an example. Perhaps you want to listen to a podcast, and you've listened to several before, and the recommender system can recommend future podcasts that you might enjoy. We can also use AI sorting algorithms for health diagnoses and facial recognition. These AI sorting algorithms need to be both sensitive, so we don't skip important data, and specific, so that you don't find things that aren't there. So here's an example. Let's say that you want to search for Dalmatians. These black and white dogs, right? A sensitive algorithm would find the dog on a white rug or find that small dog on a big fire truck, and a specific algorithm doesn't find cows, doesn't find children in a dog costume, it doesn't find zebras. It just finds Dalmatians. You can have a system that has false negatives and false positives. A false negative is when an item is defined as no match when it should be, such as if a sick person is told they're okay. A false positive is when an item is identified as a match and it is not, such as if a healthy person is told they're sick. Both false negatives and false positives are bad. For example, if we treat someone who's not sick, they may have pain and expense when they didn't need to. If we don't treat someone who is sick, then they may get sicker. So it's important that we refine these AI sorting algorithms to balance between the sensitive and the specific to eliminate both false negatives and false positives. And not everything is black and white. Usually we need results that are on a spectrum. So even in medicine or labeling that podcast that we want to listen to, we need a balance of the algorithm finding, narrowing down what we need, and a human deciding those final steps. Here's an example. Let's look at some pictures. What is swimming? Is it these kids in a competition? Is it kids playing at the beach? How about if they're riding on rafts? How about these surfers? What about water polo? How about this fish? Which of these would you label as swimming? We have to decide. It might be a spectrum. Maybe we're looking for a certain type of swimming. You can play with this at crowdsource.google.com. Then we can explore more about AI sorting algorithms and how they're used for identification. Hi, I'm Charlotte, and I'm here to talk about artificial intelligence. Did you know that one of the primary goals of AI systems is to interact naturally with people? These are AI systems that learn human patterns of speech, our gestures, and our affects, and then are programmed to respond appropriately. Natural interaction may be used to create interfaces that feel normal to us so that we feel comfortable using the technology, or to process human movement and speech patterns that keep us safe. There are 3 common areas of natural interaction. The first is speech, anything to do with talking. The second is gestures, hand and body movements. And the third is affects, tiny movements and inflections that cause us to feel something, like how we believe an actor on the movie screen. So the first area, speech, could be text-to-speech, could be speech-to-text, it could be Google Duplex, making a phone call on your behalf where the person on the other end doesn't even know that a computer has called them. It could be autocorrect. When you are sending a text, it could be Gmail that fills in your email with the speech patterns that you've used in the past. And it can be a screen reader where someone has sent you a document and it reads it out loud to you. Speech also includes translation, but don't use it for your homework because the culture and the nuance is lost. It's okay in a pinch though, if you're trying to talk with someone in another language. The second area of natural interaction is gesture recognition. This is any way that you move your hands or your body to communicate. The most popular, least expensive technology that you may have encountered is the Xbox Kinect, where you're dancing or playing a sport and your movement is recognized on this computer screen. You can also see sometimes in movies where they resize a window, something like that, where you're just showing with your body. That's not quite here yet, but it's coming soon. Also, these gesture recognition systems can recognize patterns in how people move their bodies to identify a shoplifter or to protect a crowd from someone who may be violent. The third area of natural interaction is affective computing. That's with an A, and it's the study of how computers can process human emotions. This is our tone of voice, the tiny movements that we make to convey how we're feeling, and our facial features that show that we're happy, we're sad, we're angry, we're excited. We often think of this in our mouths, but you can see it in the eyes too. Look. Right? You try it. And we can use these gesture recognition systems with affective computing to tell if a driver is getting sleepy, if they're texting, if they've been drinking, and that'll keep people safe on the roads. Natural interaction is an area of computer science research that makes AI systems accessible to everyone, and it processes the things that we do automatically, like tone of voice and positioning of our bodies, into a format that computers can understand. Then programmers can write systems that interact with us in a way that makes us comfortable and safe. Hi, I'm Charlotte, and I'm here to talk about artificial intelligence. Did you know that computer systems build representations of the world and then perform reasoning on them? A representation is a way to describe a system using the relevant features. Think of a subway map. We don't show the trees and the cross streets, we only show where the subway can stop. And we apply reasoning to that by planning your route, figuring out where you need to go to get from MIT to the Red Sox game, red line to green line. An AI system uses computer vision to construct a representation and then performs reasoning on that are choices within that representation. For example, the Cosmo robot. The robot has computer vision and can identify things like blocks, it can identify you by name, it can identify your dog or your cat, and it knows where it is on the table. Then it can perform reasoning, such as picking up a block, saying your name, or playing a game with you. You can also have representations of things that don't see, like the BachBot or Google Doodle, where you can play with music. There are features in this music. Those features are things like the note duration, the type of instrument that's playing, the pitch of that, and all of those things together make up a representation of the music. You can think of that like sheet music. And what comes next is the reasoning that we can apply so that we can make Bach-like music, following the same patterns that we identified in the features. Or let's say you want to create an application to help you find the perfect Girl Scout troop for you. We can identify features that would make that possible, such as what grade level the girl is going to be, the location of the troop meetings, the times that work for your family. And then we can actually say things like whether or not this troop often does STEM activities, or if they like outdoor adventures or service projects. And then we can put weights to those so that we can say, you know, I want to weight outdoor adventures higher than I want to rate service projects. And I can find a troop that's just right for me. You can try out representation and reasoning using Google's Deep Dream Generator. You can apply an artistic style to an image that you upload and see how the representation takes the features of that art and applies it to your image. Try it today. It's fun. It's practical. It's cool. Hi, I'm Charlotte, and I'm here to talk about artificial intelligence. When you hear AI, do you think killer robot?
Get out.
That's an archetype. It's like if I ask you to think of a word that starts with C, do you think of cat? That first leaf of your brain often isn't true, and it often hides things that we've grown up with. Like maybe you're not a racist, but you've grown up in a system that has racism. You might exhibit some behaviors that you have to overcome. You have to dispel the myths that are the archetypes in your brain, and AI is that way. The killer robots are not what you think. AI is not weaponized, and the vast majority of AI is just algorithms with data in computers. But we've grown up with stories like Robbie, Lost in Space, HAL 3000, The Hound from Fahrenheit 451, The Terminator, The Matrix, and Detroit Become Human, depending on what generation you were in. And we think that those are AI, but our overlords are not coming. There's no evidence that we have artificial general intelligence. These computer systems are not making plans on their own. They don't have any autonomy. They don't have emotion. They're not alive. They are only as good or as bad as the tasks its human creators assign to be accomplished. But people are building autonomous lethal robotics on their own. These are computer vision and navigation systems that can move independently and target selectively. They do have the capacity to kill through onboard weapons. So if you take a robot like Boston Dynamics Spot, or the parkour robot that you see here, and you can see that it moves in some ways better or faster than humans can. It has a limitation, its battery, and some of the navigation is remote controlled, but it can navigate difficult terrain, it can jump, it can go into dangerous areas. And these robots are being designed to do good work for people, like search and rescue, dealing with landmines, fighting fires, working in dangerous construction sites, or cleaning up nuclear waste. But we also have soldiers in Arizona that are flying drones in the Middle East. They're eliminating potential targets remotely. Then they're going home to dinner. Some people say that autonomous lethal robotics will save soldiers' lives. We know that military technology moves into our local police forces. So we need to ensure that autonomous lethal robotics are regulated through ethical, political, and legislative processes. The most important thing is that you're informed that AI can be used in this way by people making decisions. In 1980, we had blinding laser weapons. They were banned from the battlefield across the world. In 1997, we banned chemical weapons, and even before that, in 1928, we had the Geneva Convention. So political action and treaties can work. Once you get the cat out of the bag, like nuclear, it's really hard to stuff it back in. So what we need to do is share your awareness of autonomous lethal robotics. Write to your representatives and make some noise. We can create common sense legislative protections so that people aren't allowed to build and deploy systems that decide life and death on our behalf. And we can use AI for positive change. Hi, I'm Charlotte, and I'm here to talk about artificial intelligence. Have you heard in the news about deep fakes? It's where you very carefully place one person in a video with another person using artificial intelligence. It is real, but there's a lot of misconceptions about this technology. First, you take a person's face and you mark the points around their face, like their chin, the corners of their mouth, the corners of their eyes, and then you can map those points to another person so that you can swap out one person for another. You can see this on a technology like Snapchat, where you're adding maybe a goatee to someone's face or you're putting food on their head. A funny example of seeing this technology in action in a deepfake is the video Full House of Mustaches. Check it out. The big worry about the deepfake technology is that fake news could result in this. You could have a politician saying something that they didn't really say and have that be broadcast. But the reality is that so far, this has only been used for comedy or to show what the technology can do. Here are 3 things to reassure you. The first is that politicians are very interested in creating legislation that protects them from deepfake technology. They don't want to be seen saying something that they didn't actually say. The second is that technology companies are identifying videos that are created with this technology and then can remove them automatically. And the third is that people are thinking critically about these technologies and they are aware that they're happening, probably because there's some funny content out there. So stay vigilant, have fun, and be aware of deepfakes. Hi, I'm Charlotte, and I'm here to talk about artificial intelligence. Have you heard of word vectors? How about natural language processing? Today we're going to talk about those ideas. Natural language processing is the way a computer understands what you say out loud in a regular voice. It's part of natural interaction. Your phone is very good at understanding and translating what you say out loud to written communication. Even tricky homophones, like pour, not having enough money, and pour, like pouring your juice, or telling a tale versus a mouse's tail. You can try this on your phone, or in translating by speaking out loud and having a document write for you. Your phone does not understand the words that you're saying, but it does know associations between words. For example, llama. Llama is very closely associated to alpaca. It's also closely associated to farm. It's also associated with clothing or stuffed animals. It's not as associated with the word tire, for example. So llama can be related to a lot of different things that aren't just related to farms. But what we have to determine for natural language processing is how similar a word is in the text compared to other words that are found in text. And if you searched the whole internet, you could make a lot of comparisons. It used to be on the SAT that you'd be asked analogy questions like, popcorn is to butter as fries are to what? And you might say ketchup or mayonnaise, but you probably wouldn't say tiger, right? There are words that are more closely or less closely related to one another. And we can rate the closeness of words using math. You've done this too, probably with a game called 20 Questions. But a computer asks about 300 questions. And we can sort these words like llama into categories. We can say, it's an animal, yes or no? Yes. Is it a computer? No. Is it a cooking word? I don't think so. Let's go with no. How about farming? Yes. How about clothing? Also yes. So as we choose those yes and no values, we can say that words are more or less closely related to one another and give them a mathematical value. Then we can do math on them, like man is to king as woman is to, hopefully we'd get queen, right? But we can do king minus man and get some value that's like royalty. And we could do royalty plus woman and come up with queen. That's how these word vectors work. They make associations and we can do math on them to find what words are related. You can play with this too with wordsimilarity.com. Give it a check out. You can even see words in different languages and how they're related. And then maybe you'll see how closely llama is related to alpaca. If you want to get into the meat of this, Word2Vec is the place to go. That is more for people who are very technical, but you can play with word vectors as well. Hi, I'm Charlotte, and I'm here to talk about artificial intelligence. Last time we talked about word vectors. Let's talk about a bigger concept, vector representation. How a computer can recognize an object based on the features that it has, or those attributes. For example, think about the game 20 questions. Perhaps you're starting with, is it an animal? Yes or no? If it is an animal, is it a farm animal? Yes or no? Is it a livestock animal? Yes or no, right? We could ask all kinds of questions to learn about what type of animal we're trying to identify. Those attributes are the vectors that an AI system can use to identify unique individuals. So for example, dog breeds. We might have short or long hair, we might have weight under 50 pounds, we might have whether or not it's used for hunting or sporting. These representations are vectors that are often in fancy places like arrays or multidimensional spaces, but you can think of them on a spreadsheet. Could I ask a question and say yes or no? Those zeros and ones build a unique identifier for each thing we're trying to represent. So we can break down dogs into large and small. We can break them down into their hair type. We can break them down into what type of work that they do until we get a unique number for each one of them. All those zeros and ones add up, and the more that we see the same types of ones and zeros, the closer those dogs are together. Like our sporting dogs might all be larger dogs with shorter hair, or our toy dogs might all have smaller bodies, right? We can start to compare those features, those representations, to identify them uniquely. The closer the numbers are, the more related they are. And this is how computer systems break down something really difficult, like what is a dog, to break it down into individual features, and then they can represent that digitally in order to build a representation of the world.